In this question, there is a pulley on which a string is passing, and the ends of the strings are attached to 20 kg and 10 kg block, which are kept on the ground. Now a force F is applied on the pulley in upward direction, and we have to find out the accelerations A1 and A2 of both the blocks, and the forces are given with the different magnitudes 124, 294 and 424. So that is the same force, but the different magnitudes we have to apply, right? So let's say in the case 1 what can happen. In case 1, that is the force is 124 Newton. So when 124 Newton force is applied over here in upward direction, there will be a tension created downwards on the pulley. You can see the pulley, you can say it is a massless pulley. It is given in the question, by the way. I have not mentioned it is a massless pulley. So now if I draw the free body diagram of the pulley, I will get F is equal to 2T, because 2 times the tension is downwards and force F is upwards. Now from that, the tension in this particular string will be same, right? It is the same string, so this tension and this tension is also same. So the tension will become F by 2, and the tension T will be 124 divided by 2, that will become 62 Newton, right? That will be 62 Newton. And now this is a 20 kg force. So here 20 kg mass. So the downward gravitational force is 200 Newton. Downward gravitational force is 200 Newton, and here also it is 100 Newton, 10 kg block. So this 62 Newton is not sufficient to move any of these two blocks, 10, 20 kg and 10 kg. So in the first case, that is case 1, your accelerations will be 0. A1 is 0 as well as A2 is also 0. Now let's look at the case 2 when F2 is 294 Newton. So for case 2, let's change the color. Case 2, we have the force F2 as 294 Newton. So again we will use the same logic, and here instead of 124 we have 294. So let me erase this. The new tension we will have. So this is F2 by 2, right? So this T2 is the new tension. So the new tension will be 294 divided by 2 on both the cases, on the both the strings. So if I divide by 294 by 2, what I will get? Newton. So here upwards 147 Newton force will be there, and here 147 Newton force upwards will be there. Now obviously 147 is less than 200 Newton, so 20 kg block will not move upwards, but you can see from here 10 kg block can move upwards because 147 is greater than 100 Newton. So acceleration of the first block A1 is 0, and what will be the acceleration of second block? We have to find out. So that will be T minus 100 is equal to 10 times A2. This is the free body diagram. Tension is 147 Newton, so it will be 147 minus 100 is equal to 10 times A2. Now 147, this is 47 by 10 is equal to A2. So A2 is equal to 4.7 meter per second square. So this is 4.7 meter per second square in the second case, right? So let's look at the case 3. In case 3, what will happen? Let me erase this again. So this is for T3, right? So I will erase it again. This also I have to erase. For case 3, let's use different color. Let's use red color. Again, the same thing. T3 is F3 by 2. So what will be T3? 424 by 2. 424 by 2 will become 212 Newton. So 212 Newton force is upwards in the form of tension. So now 212 is greater than 200 and 100 as well. So that means both the blocks will start moving upwards with certain acceleration. So let's find out that acceleration. For 20 kg block, again I will draw it here, 20 kg block. Upward force is 212 Newton, downward force is 200 Newton. So the net force is 212 minus 200 is equal to MA, that is 20 times A1. So this is 12 divided by 20 is equal to A1. So this will be 0.6 meter per second square for A1. Now for A2, what will be the value? For A2, this is a 10 kg block. So downward force is 100 Newton. Upward force is 212 Newton. So the net force is upward. So 212 minus 100 is equal to 10 times A2. So this is 12 by 10 is equal to A2. This should be 112. So A2 will be equal to 11.2 meter per second square.